first responders to injury and inflammation. They help maintain the gut's barrier to keep toxins out. They just do a bunch of different things.
How could we not know this stuff over all these years? You know what I'm asking? We say we're so smart about neurology and whatever, and not know something really basic like the gut.
I think it's mostly because of the advances in cell biotechniques that we've started to really understand and be able to untangle the forms and the functions of glia, like new imaging techniques and fluorescent labeling and genetic manipulation. Like we didn't have all of those decades ago, or to the extent of like how advanced they are today. We didn't have those advanced methods back then, so it was hard to disentangle. First of all, it was kind of hard to like figure out what glia were doing independently from neurons because they're so entangled.
Let's talk some more about this research that shows that the glia actually sense when food moves through the digestive tract. Do we know how they do that?
Yeah, so that was a really cool piece of kind of new research. So there was this group that was looking into trying to figure out the diversity of glia that exists in the gut, because that's another really cool aspect, which is what are the subtypes of glia? What are they each doing? And while they were really digging into this, they found a subtype that they dubbed hub cells, and they found that those hub cells are actually able to sense force. And this is something that neurons can do, you know, to sense food in the intestines and kind of move it along. But they didn't know before that glia can also do this, which is really fascinating. So they, like, at least a subset of glia are involved with helping to move food along.
Because they sense the force. Maybe that's what they sense when you get punched in the stomach. You know?
Maybe.
Maybe. They can sense force inside. Maybe they can sense that kind of impact. I imagine that if we better understand the role of glial cells, especially when we're talking about the gut there, right? That we might come up with better treatments for what, gastrointestinal disease, autoimmune disorders.
Yeah, absolutely. And that's a huge area of effort that's going on right now, is to target glia, whether in the gut or in the brain, because as we're learning all of these new functions that glia are playing, scientists are realizing that they could potentially be a good target for these various, you know, problems that happen. And the gut particularly, because we are known to activate immune cells, they're suspected to play a role in a lot of the gastrointestinal disorders and diseases, which make them a good target. And like I said earlier, they have been found to be first responders to injury or inflammation in the gut, and tampering that could lead to an inflammation response.
Yeah, because we know how inflammation is. It's called immune disorders a lot, and that might be really good finding.
Right? Exactly.
Do we still not understand about glia? What do we need to know? It's probably too big a question, but I have to ask.
Oh yeah. I mean, there's so much that we still don't understand about glia. So one thing is just the nuances of how they're interacting with the neurons. Neurons and glia can't function independently. Their interactions are critical for the survival of the nervous system and everything generated within it. But their partnership is like still kind of mysterious. Like what is directing what? What's the cause and effect? And then there's also the other question of the diversity of glial cells. How many subtypes exist, and what exactly do those subtypes do in the brain and the gut? And, you know, some of the researchers that I talked to were like focusing on that question specifically because they thought maybe those subtypes could be functioning in like a different way for different diseases. And then, of course, like there's the translational aspect, like if we actually target glia to treat some of those neurodegenerative conditions or gut disorders, how well will those treatments be? I mean, I think it's like really exciting because I mean, not
do so many different things, are we making a mistake lumping them all together as one type of cell?
Yeah, so I think this is